Hi there, Mr. Sutton here with the AB Calculus 311 Classwork Extra Practice Solutions on derivatives of logarithmic functions. On this problem, this is actually a little trickier than it needs to be. We're trying to take the derivative of ln of 1 over 1 minus x. So this looks like it might involve a chain rule with a quotient rule, but we can shortcut the process a little bit. I'm going to start by rewriting the stuff in here as parentheses 1 minus x to the negative 1. And the reason this is going to help me out, since I'm taking the log of some expression to an exponent, I can pop out that exponent as a negative in front of the log. So I'm really taking the derivative of negative ln of 1 minus x. Okay, well this is just going to be negative 1 over 1 minus x times the derivative of 1 minus x, which is negative 1, so be careful with that. That all multiplies out to positive 1 over 1 minus x. So that's going to be, let's see, pick it carefully here because A and B look kind of the same. It's going to be choice A. On this problem, they want the limit as h approaches 0 of this ln business here. This is the limit form of a derivative. We're basically being asked to differentiate something when x equals 2e. So let's find the original function, which is just ln. It's whatever x plus h is being plugged into. Derivative of ln, which is what they want us to do here, is 1 over x. And now they want to know the derivative at x equals 2e, so this is just going to be 1 over 2e, which gives us choice A. To take the derivative of ln of e to the 2x, you could use a short chain rule, or you could make this problem even shorter, recognizing that ln and e cancel each other out. So this is really just the derivative of 2x when all is said and done. Derivative of 2x is just 2. Choice E. For this problem, we're given the equation sine of x equals e to the y. We want the derivative in terms of x. So there's a few ways to do this problem. You could implicitly differentiate, but since you eventually want this in terms of x, it's going to be better if you can isolate y if at all possible. And it is possible. If we take the ln of both sides, we're going to have ln of sine of x and ln of ey. The y is going to pop out, and ln of e just is canceling out to give us 1. So we can write this as ln of sine of x equals just y. All right, well, let's just take the derivative of ln of sine of x then. That's going to be 1 over sine of x times the derivative of sine, which is cosine. Well, cosine over sine, we can actually simplify that to cotan. So that ends up being our y prime on this one, cotan of x, choice C. For this one, they want to know the slope of the line tangent to the graph of ln of 2x, where x equals 4. So we just need to take the derivative of this function and plug in 4. Derivative of this, we're going to have 1 over 2x times a tail of 2. So that ends up being 1 over x. And just plugging 4 into that, we end up with 1 over 4. So that's choice B. For this problem, we have x squared plus 1 to the x power, and we want the derivative of this in terms of x. So since I have an x in the exponent and the base, and I don't have a way to simplify that away, I'm going to have to use logarithmic differentiation. So let me start by taking the log of both sides. I'm going to call this f of x y over here. So I'm going to say we have log of y, or ln of y. I'm going to use ln because it's easier with ln. And on the right side, I can pop out this x. So I'll have x ln of x squared plus 1. Let's implicitly differentiate now. On the left side, that's going to be 1 over y times dy over dx. On the right side, I need the product rule. So let me set up my box and ribbon. I've got factors of x and ln of x squared plus 1. Derivative of x is 1. Derivative of ln of x squared plus 1 is going to be 1 over x squared plus 1 times the derivative of this inner function, so that's going to be a 2x, and I'm just going to put that right in the numerator here. Let me go ahead and use the ribbon to multiply this out now. So on the right side of my equation then, I have ln of x squared plus 1 plus x times this stuff here, so I can actually write that as 2x squared over x squared plus 1. And at this point, I need to get dy over dx by itself. So let me multiply both sides by y to get it over here. Unfortunately, none of the answer choices have a y in them, so you actually have to replace this y with what y equals in the beginning, this x squared plus 1 to the x. So I'll write x squared plus 1 to the x times all the stuff in this brackety parentheses. So that's really the only change here. And that's going to match answer choice E. For this problem, we've got a few steps. They want the slope of the line normal to the graph of y equals 2 ln of secant of x at x equals pi over 4. So first step, we need to take the derivative of this thing and find the slope of the tangent line at pi over 4. Then we need to take the opposite reciprocal of that number to get the normal slope. All right, so first things first, derivative. So derivative of this thing, we're going to have derivative of the outer function here, which is 2 times the ln of something. So that's going to be 2 over something, so 2 over secant of x. Now we have to multiply by the derivative of secant itself, which is secant of x tan of x. And we can actually simplify this, canceling out these secants to get just 2 tan of x. At this point, now to get the tangent line slope, we have to plug in pi over 4 to this expression. Now the good news is tan of pi over 4, or tan of 45 degrees, is just 1. So this is just 2 times 1, which is just 2. But wait, we're not done, and there's an answer choice waiting for you if you thought we were done. But remember, we want the normal line. So we need the opposite reciprocal of our tangent line slope of 2. So that's going to end up being negative 1 over 2, which is answer choice B. On this problem, I'm given this equation, and I want to figure out the derivative of this thing when x equals 4. And the only other piece of information here is they're telling us that y is 4 when x is 4. So we have the point 4 comma 4 that is going to be plugged into our derivative. Let's go ahead and differentiate implicitly on this one, because it's going to be tough to isolate y. So going from left to right, derivative of ln of x, that's going to be 1 over x. And then we're going to have minus 1 over y dy over dx, because we're going implicitly with our derivative here. So y is an inner function. This is going to equal dy over dx, the derivative of y. 4 gets differentiated away, so we'll just not bother writing it. And at this point, let's isolate dy over dx. So let's keep this negative 1 over y dy over dx term on the left. And then I'll subtract this other dy over dx term to be there with it. This 1 over x term, I can move that over to the right side. And I'm going to do a couple things on the next step. So I'm going to factor out a dy over dx, actually. That leaves me with negative 1 over y minus 1. And now I'm going to go ahead and divide everything by this parentheses to get dy over dx by itself. When I divide, I'm also going to reduce all of these things by negative 1. So I'm going to end up with positive 1 over x over positive 1 over y plus 1. No need to keep all these negatives around if I can get rid of them all at once. At this point, before I plug anything in, I'm actually going to clean this up a little bit so I don't have so many fractions floating around. So let's see here. Let me combine the stuff in my denominator. I have a common denominator down here of y. I can rewrite this as 1 plus y over y. And now let me change flip this thing. So I've got a y in the numerator. In the denominator, I'm going to have this x and this 1 plus y. At this point, let me go ahead and plug in the point 4 comma 4. So I've got the y value 4 divided by the x value 4 times 1 plus the y value 4. So this is going to end up being, let's see, I can actually cancel out these 4s. So that's just going to leave me with 1 over 5. And that's going to be answer choice B. On this one, I'm trying to find the derivative of this function at x equals 0. Let me start by taking the derivative in terms of x. So using my ln rule, this is going to be 1 over all this stuff times the derivative of x plus 4 plus e to the negative 3x. Going from left to right, derivative of x is going to be 1, and I'm just going to put this directly in the numerator since I'm going to be multiplying by it anyway. So we've got a 1 minus, and this is going to be 3e to the negative 3x, because this would normally be e to the negative 3x, but we have a tail of negative 3 as well, the derivative of negative 3x. And let's see here. Now I have to plug 0 into all that stuff. So this is going to be e to the 0, which is just going to be 1. So this is really just 1 minus 3 in the numerator, so negative 2. Downstairs, we essentially have 4 plus 1. So we have negative 2 over 5, and that's going to end up being answer choice A. On this problem, I'm trying to find the derivative of ln of x over x. So this is just kind of a straightforward quotient rule on this one. U prime v minus uv prime over v squared. That's what we'll be working with. Let me set up the box and ribbon to organize things. I've got my numerator of ln of x, denominator of x, and now their derivatives. Ln of x, that's going to be 1 over x for the derivative. Derivative of x is 1. Using the ribbon to put it back together, I've got 1 over x times x, which is just 1, so this u prime v term is really just 1, minus ln of x times 1, so minus ln of x, all over v squared, which in this case is going to be x squared. And does that match an answer choice? It does, answer choice D.